The effect of outliers. An outlier is a very high or very low score in a data set that is clearly apart from the other scores. It can occur for a variety of reasons and should be investigated. For example, it may have been obtained as the result of an incorrect measurement. And if it has been obtained as the result of an incorrect measurement, it should be excluded. All right? So, however, there is a formula for outlier. An outlier is a score that is either less than Q1. Isn't that the lower quartile? Minus 1.5 times the interquartile range. Or it's greater than, the score will be greater than Q3, which is the third quartile, plus 1.5 times the interquartile range. So, before you use this formula, you have to work out Q1, Q3, and the interquartile range for your set of data. Okay? And then you apply the formula. The formula is on your formula sheet. Okay? So, that's how you can confirm it's an outlier. You can look at it and say, yes, I think it's an outlier, but to confirm that it is an outlier, you have to do these calculations. When would you use the first one if the outlier is at the bottom end? And when would you use the second formula? It's when your outlier is at the top of your data. Okay? So let's have a look. We're going to do some questions with this. So outliers can affect the measures of location of a data set. Now, if you worked out the mean, let's say you did all these tests and you did really well, but in one exam you did poorly. Is that going to lower your average? Yeah, but let's say you did average in all your tests and then you did really well in a test. That's going to increase your average. So the mean is the measure of spread that is most affected by outliers. The median can be affected by an outlier because when you take off that one score at the top or bottom, the mean might be the next score or the next half score along. You know how we say, yes, 15 scores, let's put 7 on the left, 7 on the right, the one in the middle is the median. But if I took an outlier away, so for example, if I had 15 scores, put 7 on the left, 7 on the right, this one is the median. But if I had an outlier at the top and I took it away, then I've only got 14 scores, 7 on the left, 7 on the right, the median's there. So it sort of moved half a score away. So median's only slightly affected. Sometimes it won't be affected if the two middle scores might be the same. It won't be affected. But it's slightly affected, or it can be affected. The mode is not affected at all if you take away an outlier. You're still going to have that big high peak of the score that occurs the most. All right, so mode is not affected at all. Okay, let's look at this question. So, in a small business, whenever you're doing questions like interquartile range and stuff like that, you've got to make sure your data is in order. Sometimes then it's not in order. You don't have the smallest to the highest. So in a small business, we've got 7 employees. They earn those wages. Is the wage 970 an outlier for this set of data? Justify your answer with calculations. So, is this outlier at the top or the bottom of the data? Top. So let's work out our interquartile range. Look at the formula. It's an outlier if it's greater than Q3 plus 1.5 times the interquartile range. Well, I've got 7 bits of data. So let's do our little diagram here. I've got 7 scores. How many to the left, how many to the right? 3 to the left, 3 to the right. The one in the middle is the median. But then I've got to break the other 2 sets of data up. How am I going to break up 3 scores? 1 to the left, 1 to the right. The one in the middle is your Q1. Sorry about this. One sec. And for this other 3, 1 to the left, 1 to the right. The one in the middle is Q3. Look, it's easier to probably do it on the data up there. So you okay with that or not? All right, so let's go up. 7. 7 numbers. I'm going to write them here. 300, 490, 520, 590. You can actually just, you're lucky it's 7 because you can just pick them out. 1, 2, 3, 1, 2, there's your median. Where's your Q1? 1, 2, 3, isn't that one Q1? And where's Q3? 680. So we've put down what Q1 is, Q3, and the median. I know what Q1, Q3, and the median are. What do I need to work out? The interquartile range is Q3 minus Q1, which is 680 minus 490, which is what? Sorry? 190? So now, we think that which of these two do we use? It's the greater than. Outlier, if it's greater than Q3 plus 1.5 times QR. You wouldn't do down the lower end. The outlier that you're looking at is at the top end of the data. So your score, so I'm going to go Q3 plus 1.5 times IQR is, ready?
Do you have to do
Q3, which is 680 plus 1.5 times, what's the IQR? 190. Do you know why I'm doing the greater formula and not the lower, less than? Because our outlier we think is at the top of the data, not at the bottom. All right, so what do you get for this? What's 680 plus 1.5 times 190?
965.
So 965. So is your value that you're looking at 970, is it greater than 965?
How do we get the 1.5? Did we just conjure the formula?
It's in the formula. 965 for our calculation. Now looking at the definition, an outlier is a score that's greater than Q3 plus 1.5 times IQR. And our score that we're looking at is 970, the outlier. Yes, it is, because 970 is greater than the answer there, which was 965. Now, part 2, that's part 1. Part 2 asks, each employee receives a $20 pay increase. What effect will this have on the standard deviation? Now, what would be, each employee receives a $20 pay increase, then instead of 300, 490, they'll get 320, 510, 540, 610, 680, 700, and 990. Do you think that those numbers are more spread out than what they were before? They're not. They're not more spread out. What do you think? What I want you to do, I want you to go into your calculator actually, and I want you to enter those first 7 numbers, work out the mean and standard deviation. Then I want you to clear everything and then do the next 7 numbers, which are $20 higher, and do the mean and standard deviation. Now, you tell me before you start, do you think the mean's going to increase? By how much? Yeah, the average should increase by $20. All right? The average will increase by 20, but the standard deviation should stay the same. Okay? Because they're not more spread out from each other than what they were. Remember, standard deviation is the spread of the scores from the mean. So yes, the mean for this second set of data is $20 higher than the first, but the scores are still spread out the same way as they were from the mean. So what I want you to do, if you're not sure about that, I'd like you to work out the mean for the first 7 numbers and standard deviation, and I want you to write them down. But remember, girls, this question's only worth 1 mark. They're not expecting you to work this all out. All right? And if you worked out for these 7 numbers the mean and the standard deviation, you should find that the mean is 20 higher than the original set, but the standard deviation will be identical because it's the spread of the scores from the mean is still the same. So the answer is, what effect will this have on the standard deviation? You'll say the standard deviation stays the same because the scores are still spread out exactly the same way from the mean. So what I would say, let me write it somewhere. I'm going to write along the side of the page. Is that all right? So I'm going to write here that the mean, so this is for part 2, the mean stays the same. Sorry, no, the mean does not stay the same. Sorry. The mean increases by $20 and the standard deviation. So the mean increases by $20 and the standard deviation stays the same because the scores are spread, are the same spread. The scores are spread the same way from the mean. Do you know what I mean? Okay? So the mean will increase by $20, but the standard deviation will stay the same because the scores are spread the same way that they were originally from the mean. It's still the same spread. Now you can confirm it. You can confirm it by doing the mean and standard deviation for each set of data, and you can do that at home. All right. Range for the first set of data, it's 670. 970 minus 300 is 670. Look at the spread when we've added $20 on. 970 minus 320 is 670. Same spread. Look at the next two inside, subtract each other. You get whatever you get, 190. These are 190 apart as well. Everything's spread out the same way. Okay? They're not more spread apart. See, if I now added, instead of 990, like 1,500, that would change the standard deviation. But the numbers are still spread apart exactly the same way. Look, 300, another 190 gives me that, add 30 gives me that, add 70 gives me that. Same jumps from each number in the bottom set of data. They're spread out exactly the same way. They just happen to be 20 marks higher, so the mean will be higher by 20, but the standard deviation stays the same. All right, next question, specimen paper, question 27C. So these are both HSC questions, all right? Data was collected from 20 students, so we know that there's 20 there. Number of text messages. So, let's just have a look at the data, by the way. Positively or negatively skewed? Yeah, start on a positive note. You can write that down if you feel like it. So it's positively skewed. What's the interquartile range, and is 51 an outlier? Yes.
How can you be sure?
Bits of data is there? How many bits of data? Read your question. 20 students. What do I do with that number? 20. What do I do? 10 on the left, 10 on the right. What's in the middle? The median. Now what do I do? 5 on the left, 5 on the right. Q1 is there. 5 on the left, 5 on the right. Q3 is there. All right, you're going to have to go in and put where Q1, Q3 and the median are. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a line, that's your median. Make sure there's 10 after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. Q1. 1, 2, 3, 4, 5. Put a line. Good. Make sure there's 5 after it. 1, 2, 3, 4, 5. Good. And then 5. 1, 2, 3, 4, 5. Put a line. Make sure there's 5 after it. 1, 2, 3, 4, 5. Looks good. So, question 1. What's Q1? 12. What's Q3? And the interquartile range is 28 minus 12. It's 16. Now, with the outlier formula, we're going to use the greater than or the less than one? The greater than. So, I'm looking at Q3 plus 1.5 times IQR. So what's Q3? 28 plus 1.5 times 16 is, I think it's 28 and 24, 52. Is it 52? All right. Now, go back to the definition. An outlier is a score that is greater than this. Is your score of 51 greater than that? No. So 51 is less than that answer of 52. So therefore, 51 is not an outlier. It has to be greater than 52. Do you get that? All right. You know how it says on the formula sheet, the outlier is the score that's greater than? Outlier is the score that's greater than that. So I can go that or are you okay with me setting it out this way? All right? Your 51 has to be bigger than the 52, but it's not. All right? 53 would have been an outlier. So, you know, normally we'd look at that and say that's an outlier, but according to the definition, it just misses out. All right? 2007 HSC, question 24. Consider these scores. You have to calculate the mean of the scores, and then you have to, what is the effect on the mean and on the median of removing the outlier? It does not say what do you think would be the effect on the mean of, which one's the outlier, by the way? All right. Let's just do part one. What is the mean? I'm going to quickly add them up. 50, 60, 70, 79, 88, 96, 102, 112, 115. So the mean is 115 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 11.5, the mean. Part two, what is the effect on the mean and on the median of removing the outlier? If you remove the outlier, you should actually be able to tell me what, well, you don't even have to work it out. But what would happen to that mean? Oh, is it 114? Now, won't the mean go down? You tell me what the new mean is. What do you think they would add up to? With the 50, it added up to 114. Why not just subtract 50 from this total? Is that 64? Over 10? 6.4. So what happens? The mean, if you remove the outlier, the mean decreases. And now what you have to do is work out the median with the outlier and the median without the outlier. Could you do that? So median 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. The old median is what? 8. And if you don't have the 50 in there, the new median with no outlier, I think, is also 8. Oh, yes, sorry. Divide by 9, so that's a mistake. There's only 9 scores if you take the outlier out.
Wait. So remove outlier. What's that thing?
Mean.
So just remove outlier mean.
The old median is 8. If I remove the outlier, 3, 5, 5, 6, 8, 8, 9, 10, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 scores. So I go 4, 4, and 1 in the middle. The new median is also 8. So there is no change to the median. But remember that the mean is very much affected by outliers. If you remove the outlier, the new mean is 7.1 recurring.